The last pattern I want to mention, and I don't really recommend this pattern, but I see it often, is a pattern called the generic pattern. It's also called the value pairs pattern or the EAV, meaning entity attribute value pattern. The idea of the generic pattern is that there's only 4 tables. One table holds a listing of all the categories or groups or classes. In the object table, or sometimes called the item table, there would be one row for every item, regardless of the class or category. The attribute or property table contains a listing of every attribute and every property for every class or category. So we're getting some long lists here, aren't we? And then in the value table, it's a very simple table that says, for this object, for this attribute, here's the value. And that value table could end up being millions or billions of rows long. On the positive side, the generic pattern allows you to be very flexible with your logical schema changes. You can add classes, you can add attributes and properties without any changes to the schema at all on a physical level. It's just the 4 tables. However, even though this can be very appealing, it is difficult to extract data out using normal SQL. There's also a data typing problem because the value table then has to store everything in a single data column, usually an nvarchar data type, so it can store almost anything you want to put into it. As a workaround for that data typing problem, sometimes people will build the generic pattern with a separate value table for each different data type. And although that does give you some data typing, it makes it even that much more difficult to extract out data. So while the generic pattern can seem appealing and can seem very flexible, I don't recommend it. A common complaint about relational databases is that they tend to be very complex. Some folks would call this even being over-normalized. However, I don't believe normalization is a line where you become more normalized and becomes more complex. Instead, there's a sort of a sweet spot there. And if we get back to talking about the rules of one, and think about that first rule of one, meaning that it's a group of similar items which become a table, the question then is, how do you decide what is a group of similar items? For example, do you want to have a table for SUVs, for cars, for convertibles, for buses and trucks? Or do you just want to have one table called vehicles? You might argue that there's going to be an attribute for a truck that's not going to apply to a car, or there's attributes for an SUV that won't apply to a convertible, unless you're driving a Jeep Wrangler, but that's neither here nor there. So the way to deal with over-complexity with normalization is this idea of, do we generalize or are we very specific as we decide what makes up a group of items? On the side of being very overly complex, I've seen databases that end up with 87 or more tables. When I came by and looked at the same requirements, did some generalization and came up with 17 tables to do the same thing. And without getting into the whole story, the difference there was generalization. The other data modelers saw it as a very specific set of requirements, and I looked at them and said, well, these are so similar, we can put these together and then have another table, say, type of, to get the same job done. Sometimes over-normalizing actually ends up hard-coding different types where if you generalize, you can end up making it more flexible and it's easier to add another type. For example, another type of vehicle. Using the previous example, if you had a table for SUV and convertible, car and bus and truck, and then you came along and wanted to have motorcycles, you'd have to build another table for motorcycles or another table for planes or helicopters. So normalizing to the point of being very specific with your designs and hard-coding into the designs can actually hurt the extensibility or future flexibility of the database design. But if you can generalize while you normalize, your designs will be more flexible and more extensible. They will live longer as they're able to meet the changing business requirements. In contrast to generalization, many developers feel the only option to overnormalization is to denormalize. And generalization is not denormalization. Denormalization is when you specifically take a value that could possibly represent an attribute to table A and you copy it down to table B to save that join. If that's all you're doing for normalization is to copy a single column, which is a static column, that's not a good example of when to denormalize. Some examples of how you can responsibly denormalize, improve performance of the database, and even improve the integrity of the data is to denormalize inventory on hand calculations, pre-calculate some aggregates. For example, in the order detail table, it could be argued that because we have the quantity and because we have the individual item price, that we're storing duplicate data if we calculate that out and store the extended amount. But doing so would make it much easier to sort and do aggregates and to work with that data later. The same thing with inventory on hand. It could be argued that the inventory transaction numbers should only be stored in the inventory transaction table and not aggregated and then the sum placed in the inventory table. But doing so certainly makes the database more functional. Another example of responsible denormalization has to do with historic data, and this is one limitation of the relational model. Think for a second about a customer, and we have his name and address and shipping information in the customer table, and then in the order table we're simply pointing up to the customer table. If the customer moves, but we don't have an actual history of that shipping address in the order table, then we'll have no proof of where we shipped it 3 years ago. So it's responsible denormalization to go ahead and copy that current shipping address from the customer table down to the order table. So how do you enforce responsible denormalization? Well, if it's going to be responsible, it has to be at the database level. Don't depend upon the website or the middle tier or the business logic to maintain this duplicated data. So it should be enforced by a trigger, by a calculated column, by a stored procedure, something inside the database.